Hello everyone, welcome to the Knowledge Creator. Today our topic is concept of cavitation and NPSH. Cavitation. Pump cavitation is a hydraulic disturbance that has potential to increase operating noise levels, affect the performance of the pump, cause damage to the internals of the pump. That's the reason cavitation is also called heart attack of pump. The first question arises there: how do we know that the pump is cavitating, or how we detect cavitation? It is not very difficult to detect cavitation. You can detect it by abnormal sound or vibration. It can also be detected by pulsation in the discharge pressure and the electric load. Now, after detecting, the second question arises there: what are the causes of cavitation? We know that pumps are used for transfer of liquid from one place to another place by adding energy in the liquid. It means that they are specifically designed for the liquid. Cavitation is caused by the formation of vapors in the liquid. In order to understand the detail, we need to understand the property of the liquid called vapor pressure and the concept of boiling point. Vapor pressure. It is a physical property of pure chemical component, defined as pressure exerted by the vapors in equilibrium with liquid or solid form at given temperature. For example, let's take a closed container and fill half of it with liquid. After some time, vapor form in the space above the liquid surface consist of the high energy molecules that evaporated from the surface of liquid and collected in the closed container exerted above pressure. This pressure is called vapor pressure. In case of pure liquids, it solely depends upon the temperature. Example of vapor pressure. Here you can also review your concept of boiling point. Boiling point is defined as the temperature at which the vapor pressure of any liquid becomes equal to the atmospheric pressure or surrounding pressure. You can see there at 100 degrees C, the water vapor pressure becomes equal to 1 atmospheric pressure. This is a point where water boils. For ethyl alcohol, it is 78.5, and for octane, it is 125.7. Similarly, at 20 degrees C, water has a vapor pressure of 2.33 kilopascal and isopropyl has a vapor pressure of 4.4 kilopascal. From the above two examples, it clearly depicts that alcohol has higher tendency to evaporate as its vapor pressure is higher than the water at a same temperature. After discussing the concept of vapor pressure and boiling point, back to the cavitation. In industries, very often pump handle liquid with suction condition very close to a liquid vapor pressure. When a liquid is drawn into pump inlet, there is a pressure drop resulting from the fluid friction along the pipeline, valves, fitting and the flow pattern. You can see in the figure, due to these, pressure of the fluid inside the pump decreases. When liquid reaches that area with low pressure, and if the pressure becomes equal to the vapor pressure of the liquid, that liquid will vaporize. That's how vapor form inside pump. These vapor present in the form of bubbles. When these bubbles goes to high pressure area of the pump, these bubble implosion take place that form a micro jets that collide with the casing and internals of the pump. Here you can see how bubble collapse and implode to form microjet that has a high velocity and tendency to damage the wall, casing or internal of the pump. This collision is called cavitation. Cavitation damage to a centrifugal pump may range from minor pitting to catastrophic failure. Depends upon the pump fluid characteristics, energy level and duration of cavitation. Most of the damage usually occur within the impeller, specifically on the leading face of non-pressure side of the vane. You can see here the effect of cavitation. In figure 1, minor pitting is observed, and in figure 2 and 3, the impeller vanes are completely damaged. This is how cavitation damage the pump. Thank you for your interest. This is part 1. The second part will conclude the concept of NPSH. Stay tuned.